Hey team, I'm Brains. I'm your math tutor. Today, we're going to talk about some inverse trig functions. Don't forget to hit that like and subscribe button. Let's go! Alright, so the inverse of a function basically just undoes what the other function did. So for example, you have this function f that takes all these x's in your domain and it turns them into outputs, this f of x. Well, an inverse is this function g that takes all your outputs and returns them all to those regular values x. In other words, g of f of x is x, and f of g is x. Whoa! Got you there. For trig functions, you got a couple ways to write them. Often people will write like arc sine, but you can also write them as sine to the power of -1. Now be aware, sine to the power of -1 does not mean 1 over sine. You screw that up, I can't help you. In other words, for inverses of trig functions, sine inverse of sine x is x, and sine of sine inverse of x is x. You just got to be careful of your domains and range. Here's a list of all the domain and ranges for all these 6 trig functions. Take a moment to write them down, and if you get bored, you stop the video and go get some popcorn or something. Cheers. Finding the principal values is like kind of thinking in reverse. For example, what angle makes cosine equal to 0? Well, if we take a look at our unit circle, cosine is equal to 0 when the angle is pi over 2. So cosine inverse of 0 is equal to pi over 2. Another example would be like cosine inverse of root 3 over 2 is equal to x. We need to find out what that is. What does x equal? We can look at our unit circle again, and we can find out where cosine is equal to root 3 over 2. When we take a look, it would be at pi over 6. So cosine inverse of root 3 over 2 is just pi over 6. All right, cool. Now I'm going to give you a list of important identities. You can go ahead and write them down. Take a second to pause the video if you need to. No worries there. Once you're done that, we're going to go ahead and go into some cool problems. So I'll catch you in like 2 seconds. Oh, I should probably get out of the way. Okay, this is our first problem we're going to work through. We need to show that 2 sine inverse of 3 over 5 is equal to tan inverse of 24 over 7. So we're going to show that the left-hand side is equal to the right-hand side. Okay, first thing we're going to do is we're going to let theta equal sine inverse of 3 over 5. Not a big deal. Well, then if we take the sine of both sides, we have sine theta is equal to 3 over 5. Well, knowing our trig ratios, sine theta is y over r. So then we can say that we know y is 3 and we know r is 5. We need x, so we'll use the Pythagorean theorem. X squared plus y squared equals r squared. So that'll give us x is equal to 4. Okay. Well, we've got this tan thing we're going to worry about. So let's do tan. We know then that tan theta is going to be y over x. So we've got 3 over 4. Which means theta is also equal to the tan inverse of 3 over 4. Okay, it's a good start. Good start. Now let's play with this left-hand side. We've got 2 of sine inverse of 3 over 4. Well, we said that before, that sine inverse of 3 over 4 was theta. So this is equal to 2 theta. But theta is also equal to tan inverse of 3 over 4. So we've got 2 times tan inverse of 3 over 4. Okay, Well, that's not quite what we wanted yet. We can use an identity, though, that 2 tan inverse of a value x, whatever that value is equal to tan inverse of 2x over 1 minus x squared. Okay, so let's use the identity. This 2 tan inverse of 3 over 4 is going to become tan inverse of 2 times 3 over 4 over 1 minus 3 over 4 squared. Well, what does that give us? Tan inverse of 3 over 2. Well, 1 minus 9 over 16, that would be what? 7 over 16? We've got 7 over 16. So then we're going to do division of fractions. Tan inverse 3 over 2 multiplied by the reciprocal. So 16 over 7. Oh, well, look. The 2 and the 16 can reduce. So the 2 goes away. The 16 turns into an 8. So we get tan inverse of 3 times 8, which is 24, over 7. Boom. That's what we wanted to prove. That is the right-hand side. Done. Okay. We got another question. This one again, we're going to use another identity to help prove that the left-hand side is equal to the right-hand side. So let's write down that identity. We've got the tan inverse of x plus the tan inverse of some y is equal to the tan inverse of x plus y divided by 1 minus xy. Just like our formula from before. Okay, let's use this identity. We've got tan of 2 over 11 plus tan of 7 over 24. All right, so that would be tan inverse of x plus y, so 2 over 11 plus 7 over 24 over 1 minus 2 over 11 times 7 over 24. We're going to need some common denominators here, so let's start writing things down. We'll go with tan inverse of a big number, 24 times 2, plus 7 times 11 over 24 times 11, all over. This 2 and this 24, that can reduce, so this becomes a 1 and this becomes a 12. So we've got 11 times 12. So this will be 11 times 12 when we make that common denominator, minus a 7. Common denominator will be 11 over 12, or 11 times 12, my bad. This will become tan inverse. Well, 2 times 24 is 48, plus 77 would be what? 125? We've got 125 over, let's leave it as 24 times 11 for now. 24 times 11. 11 times 12 minus 7. Well, that's 125 as well. We got 125 over 11 over 12. We're going to multiply by the reciprocal. So this will be 11 times 12 on the top and 125 on the bottom. Take a look. 125 cancels out. This 11 and this 11 cancel out. Well, 12 and 24, that's just 1/2. 1 and 2. So this becomes tan inverse of 1/2. Just like we wanted to prove. Okay, now we've got a slightly different problem. This one we're just going to solve for an answer. We got a subtraction of 2 tan inverse. We got another identity for it, so let's write that one down. Tan inverse of x minus tan inverse of y is equal to the tan inverse of x minus y over 1 plus xy. This subtraction will become tan inverse. Well, instead of x, we have x over y, so we've got x over y minus this x minus y over x plus y. And then we need to divide by 1 plus the multiplication. So x over y times x minus y over x plus y. Oof. Now we need to simplify. So let's get a common denominator on the top first. We'll have tan inverse. Well, x times x plus y. And then minus y times x minus y. This is all divided by y times x plus y. Common denominators, not a problem. We will divide. Well, this is going to be, again, some common denominator. So we've got y times x plus y on this 1. So y times x plus y. And then we've got a plus x times x minus y all over y x plus y. This is all inside our tan inverse. Oofty. Dividing by fractions, multiplied by the reciprocal. So this one here on the bottom, we'll reciprocate. So we'll have the tan inverse. And I'm just going to not multiply anything out yet. I'm just going to flip it. X times x plus y minus y times x minus y over y times x plus y multiplied by, well, y times x plus y over y times x plus y plus x times x minus y. Okay. Take a look at this. This x plus y and times y and this y times x plus y, they're gone. Well, bam. So let's multiply things out and start combining like terms then. Tan inverse. X times x plus y. That would be x squared plus xy. Minus y times x is minus, well, xy. And then plus y squared. And then let's see what's on the bottom. We've got a y times x. And then we've got a y squared. We've got a plus x squared. And then a minus xy. Well, combining like terms, x plus y and x minus y go away. And then this yx and this xy go away. We're left with tan inverse of x squared plus y squared over, well, x squared plus y squared. Well, that's the same term, so that's just 1. Well, that just gives you tan inverse of 1. So what angle would make tan 1? Well, that's just pi over 4. And that's it. Okay. This one is going to be a little bit tougher. First, let's just let theta equal to the sine inverse of x. Okay? That means that the sine of theta is equal to x. Okay? And we're going to work with the right-hand side. Before we were always working with the left, let's work with the right-hand side this time. So then we've got this sine inverse of 3 times x, which would be 3 sine theta, minus 4, well, x cubed is now sine theta cubed. And now we're a little bit stuck. I'm gonna do something. Here's an interesting little note that's gonna help us out. So remember that sine of 3x, well, is just like the sum of sine of 2x plus x. Okay? We can use our trig identity when it comes to the sum of two angles inside a sine. Sine of x plus y, well, that would be sine x cos y plus cos x sine y. So then this would become sine x plus x will become, well, sine of 2x times cosine of x plus, well, cosine of 2x sine x. Well, now we can use a couple other trig identities. Sine 2x is 2 cos x sine x. And cosine of 2x is equal to 2 cosine squared x minus 1. Our sine 2x cos x is going to become 2 cos x sine x, and then the original cos x. And then our cosine of 2x sine x is going to become 2 cosine squared x minus 1 times sine x. Well, let's take a look here and combine some things. This will be 2 cos squared x sine x. This will be plus 2 cos squared x sine x. And then we've got a minus sine x. Okay, let's add these two together. We've got 4 cos squared x sine x minus sine x. Well, remember, cos squared is just 1 minus sine squared. So we can write 4 1 minus sine squared times sine x minus sine x. And combine these, we've got 4 times sine x and 4 times minus sine cubed x. And then we still have a minus sine x. Well, we can combine terms. We've got 3 sine x minus 4 sine cubed x. Well, remember, this was just sine of 3x from the very beginning. Well, hold up a second. 3 sine theta minus 4 sine cubed theta from the beginning is equal to sine 3x. Look at that. So our whole thing from the beginning, sine inverse of 3 sine theta minus 4 sine cubed, is actually sine inverse of sine of 3 theta. Just like that. Sine inverse of sine of 3 theta, remember that just returns the inside, so this is just 3 theta. But we said that theta is sine inverse x. So 3 theta is 3 sine inverse of x. And that's what we were trying to prove. This is the left-hand side. Done. Okay. Now this one is a little bit different. We're going to solve and put this in the simplest of terms. Okay, well, we got a couple things we got to worry about here. So let's just simplify sine inverse first. So let's do this one. Sine inverse of 2x over 1 plus x squared. Let's do something crazy. We're going to let x equal to tan theta. I know it's crazy. You'll see. Since 1 plus tan squared is secant squared, we'll get a little simplification here. You just watch and see. Just watch. That means this 2x or 1 plus x squared, this is going to be replaced with tan theta. So we've got sine inverse 2 tan theta. over 1 plus, well, tan squared theta. Holy cow, look at that. Well, that means this is sine inverse of 2 tan theta over, well, 1 plus tan squared is secant squared. Let's keep going here. We got to keep going here. This is sine inverse. Well, 2 tan theta is well, that's sine over cos. So 2 sine theta over cosine theta. And 1 over secant squared is cos squared. This is just cos squared. Well, one of these cosines cancels out. Then just another step here, just holy cow. We've got 2 sine theta cos theta. Well, that's sine of 2 theta. So we've got sine inverse of sine of 2 theta. Holy cow, simplified again. This equals 2 times theta. Whew. Okay, we're going to remember this for later. Okay. Let's work on the cosine one. So the cosine inverse of 1 minus y squared plus, you know, the thing. Cos inverse of 1 minus y squared over 1 plus y squared. Let's do it again. We're going to let y equal to tan of phi. A good one. Cosine inverse. Well, this is 1 minus tan squared phi over 1 plus tan squared phi. Oh, geez, we're doing it again. This is going to be secant squared. Okay. Cosine inverse of 1 minus tan squared. Okay. Secant squared. Okay, what are we going to do? Let's do some little bit of fun division. This is going to turn into cosine inverse. Well, 1 minus tan squared is sine squared over cosine squared. Secant squared, well, that's 1 over cos squared. So this will just turn into a cos squared again. So we got a bit of a problem here. We need a common denominator. So let's turn this common denominator cosine inverse. Cosine squared phi minus sine squared phi over cos squared phi. Now we can do some cancellation. Boom. Gone. Hold up. Cos squared minus sine squared. Isn't that another trig identity? Pretty sure it is. That's cosine of 2 theta. We've got cosine inverse. Well, cos squared minus sine squared is cosine of 2 phi. Again, inverse cancellation. We've got 2 phi. Holy cow, simplifying. Let's keep that for later. Now, our original question is tan of one half of this angle is now, well, sine inverse was 2 theta, cosine inverse was 2 phi. So this would become tan 1/2 2 theta. What was it? Plus 2 phi. Okay. So we've got this 2 theta plus 2 phi. We can take out the 2's. They'll cancel out. So this will give us tan of theta plus phi. Well, let's start a new page. This is glorious. We've got tan of theta plus phi. But if you remember, another trig identity, the sum of 2 angles in tan is going to be tan of theta plus tan of phi over 1 minus tan theta tan phi. Well, what was theta and what was phi? Well, remember, that we let x equal tan theta, and we let y equals tan phi, that means tan theta is x, so x, tan phi is y, plus y, over 1 minus x, y. We're done. And that just about does it for this video. Yep, that's all I got. See ya.